Hello and a very warm welcome back to Maths Plus. Today we have a very interesting problem. It is a complex proof, and we're proving that if x plus 1 over x is equal to 2 cos alpha, then x to the power of n plus 1 over x to the power of n is equal to 2 cos n alpha. So if you're new to the channel, maybe pause the video and give it a go and let me know how you got on. And also, don't forget to subscribe. I really appreciate that. Thank you. So let's get started. First of all, we're going to let cos of alpha equal to the cos of a. Now let's turn our attention to 1 plus 1 over x is equal to 2 cos alpha. So what we want to do is create a quadratic here. We're going to write x minus 2 cos a plus 1 over x is equal to 0. Now let's multiply by x, and we will get x squared plus 2 cos a multiplied by x, and we'll have x over x. Alright, so this gives us a quadratic. And now we're going to use the quadratic formula minus b plus or minus the square root of the discriminant over 2a. Let's assign our coefficients for the quadratic formula. We can see that a is the coefficient of x squared, which is 1, b is negative 2 cos a, and c is equal to 1. Now let's substitute them in and work it out. So we'll get x is equal to minus 2 cos a plus or minus the square root of negative 2 cos a, all to be squared, minus 4 by 1 by 1, and over 2 by 1. Alright, so that looks a bit complicated, but let's simplify and let's see what we can do. Now you can see that if we square the negative 2 cos a, we will get 4 cos squared a. We have 4 by 1 is minus 4, and we have positive 2 cos a now outside. Okay, so let's examine further the discriminant. So we have 4 cos squared a minus 4a, and we're going to divide in by 2. So that means we're factoring out the 4 because 2 squared is 4 and the square root of 4 is 2, so we can factor these out here. So what we're going to get is x is equal to cos of a plus or minus the square root of cos squared a minus 1. Now let's examine this further. And we can rewrite it as x is equal to the cos of a plus or minus. So cos squared a minus 1 is negative sine squared a, as cos squared a plus cos squared a is equal to 1, the identity. Now let's progress with working on a split in the radical. So we can say negative 1 by the square root of sine squared a. We can use the Moivres theorem with complex numbers. We can say that x to the power of n is equal to the cos of a plus or minus the I sine of a, all to the power of n. And now we can distribute our n as a coefficient with the a variable inside both functions. So let's see what we have. So when we bring it in, we are going to get x to the power of n is equal to cos of n a plus or minus I sine n a. Now that we have x to the power of n, we need to work out with its reciprocal 1 over x to the power of n. And remember, that's just going to be 1 over x to the n, which is cos of n by a plus or minus I sine n by a. Now, because it's going to be have a reciprocal power, this means I'm going to bring it up as a numerator and change the actual coefficients of so it'll be negative and plus, and remember the minus cos A is equal to positive cos A because it's symmetrical off the x-axis, and we have in by A. Now in getting both options, we need to first of all take the plus and then the negative. So we have cos of NA plus I sine NA plus cos of NA minus sine of NA. So they're going to cancel and we'll get 2 cos of NA. And the counter argument then minus and then plus. So minus NA and plus NA. So therefore, it works out that x power of n plus 1 over x to the n is equal to 2 cos in A or 2 cos in alpha. And therefore, it's proven. We can say that x plus 1 over x is equal to 2 cos alpha, then x to the power of n plus 1 over x to the power of n is equal to 2 cos in alpha. So therefore this statement is true. So I hope you enjoyed the video. Thanks a lot for watching and see you again soon on the next exciting Maths Plus video.